Good morning to all. Welcome to my channel GPS of Physics classes. My name is Shekhar Reddy, Senior Physics Faculty. Today we are going to discuss about numericals on motion of a connected bodies. So in previous videos we was discussed about different conditions of connected bodies. What would mention bodies connected, one body on horizontal surface, next body vertically suspended. So one body connected with the string on inclined plane, next another body suspended, and different conditions. So here, one question: three equal masses, each equal to m, connected by a strings and passing over a frictionless pulley shown in figure. So like this is the diagram. So mass m at A, mass m at B, mass m at C, all are identical masses. Here, what is asking? Find A mean acceleration of the system. Acceleration of the system. Next, the second bit. Tension A to B. Tension A to B. Okay, tension A to B. Next, tension B to C. Tension B to C. So here, the pulley is frictionless. And the strings A to B, single string. Next, B to C, another string. So you are asking the acceleration of the system. Suppose here, one side two masses, two identical masses, mm, here only single mass. That means the motion of the bodies towards downward direction, that means acceleration here. So this direction, acceleration of. So that means mass A moves upward direction, mass B and C moves downward direction. Here acceleration downward direction, here acceleration upward direction. Suppose if you consider mass m, here fixed, the weight downward direction, tension led by T1, T1 upward direction. So up to A to B tension is same mass. Here this tension also upward direction. So A to B single string, the tension in the string this side and this side is same. Next here string changes. Tension between B and C. So with the comparison mass C. Tension T2 and B upward direction, acceleration downward direction. So here asking acceleration, tension A to B, tension B to C. First we will find the acceleration of the system. Acceleration of the system. For acceleration purpose, so initially we will draw the free body diagrams for all three bodies. Now ABD for mass at A. Mass at A. So mass at A. This mass separated from the system, that is taken as point mass. Weight of the body in downward direction, that means mg. Tension in the string, T1 upward direction. So that means acceleration is also upward. So here acceleration upward direction means the resultant force also upward direction. Here how many forces acting on the mass at A? One force, gravitational force acts vertically downward direction, tensional force upward direction. So acceleration upward means tension, the resultant force also upward direction. Now we have to write net force. F4 is equal to T1 minus mg. F4 we have to write MA. MA is equal T1 minus MG. So let it be equation 1. So next three body diagram for FBD for mass at B. Same thing. This mass separated from the system or isolated from the system and showing all forces acting on them and to draw the diagram. The diagram is known as free body diagram. And the downward direction. Here mass B, tension T1 upward direction. At the same time, so with respect to mass at C, tension upward direction, with respect to mass at B, downward direction. So here two downward forces. Gravitational force, next to tensional force, upward direction. So what is the direction of acceleration? Downward. Direction of acceleration? Downward. So here net force or resultant force FR is equal downward forces more than to upward. Downward force means weight of the body plus tension T2, upward force means T1. So this is how to write MA mg plus T2 minus T1. Let the equation 2. So next remaining free body diagram FBD for mass at C. FBD for mass at C. So same condition, this mass is also isolated from the system and to draw the diagram showing all forces. So here downward direction, only gravitational force. So tension T2 upward direction. So here tensional force on the mass at C, T2 acts upward direction, gravitational force acts vertically downward direction. So the acceleration of the system downward. So same thing result force along the acceleration. Mg minus T2. So this is equal MA Mg minus T2 at equation 3. Okay. So for all bodies we have to draw free body diagrams. From the free body diagrams make the equation 1, equation 2, equation 3. Now we are asking first bit acceleration of the system. First bit. Acceleration of the system. System is for acceleration for A equation 1 plus equation 2 plus equation 3 on both sides. On both sides. So your first equation MA, second equation MA, third equation MA. So that means MA plus MA plus MA. So right side first equation T1 minus mg. Right side second equation plus mg plus T2 minus T1. Next right side third equation. So MA is equal to mg minus T2. Right side mg minus T2. This is also added plus mg minus T2. So your right side, left side, MA plus MA plus MA. That means you have to write 3 MA. Right side, like this is plus T1 minus T1 get cancelled. Plus T2 minus T2 get cancelled. Minus mg plus mg get cancelled. So only remaining mg remaining. So mg remaining. Here mm get cancelled. That means 3a is equal to g. A is equal g by 3. G by 3 meter per second square. This is acceleration of the system. Acceleration of the system. So next what is asking? Tension A to B. Next way to second bit. Tension in the string. A to B. Tension in the string A to B. So here in first equation T1 directly will find it. From equation 1, from equation 1, MA is equal T1 minus MD, where A value substituting in this equation. That means A is equal to mg by 3. G by 3 means mg by 3. T1 minus mg. So our requirement T1. So T1, that side only mg transfer here. Mg by 3 T1. So here same 3 mg plus mg, 4 mg. Therefore T1 is equal to 4 mg by 3. So this is tension A to B. Tension A to B. So next another one, tension B to C. Tension B to C. So in third equation, directly MA is equal to mg minus T. From equation 3, MA is equal to mg minus T2. So same thing in this equation, K value substituting K is equal to G by 3. That means mg by 3 is equal to mg minus T2. mg minus T2. Our requirement means T2. So T2 transfer here. mg. So left side plus mg by 3 is there. That will transfer right side minus mg by 3. So here LCM 3. That means 3 mg minus mg. 2 mg by 3. So therefore T2 is equal to mg by 3. This is tension, tension, tension B to C. Okay. So these are answers. You should remember. So first bit A is equal G by 3 meter per second square. So tension second bit, tension T1 is equal 4 mg by 3 Newton. Third bit, tension T2 is equal to mg by 3 Newton. Okay, so this is 3 bodies connected with a string passing over the frictionless pulley. This is one model, very most important. Next, we will solve another problem. So next, solving another problem. Next question. If 3 masses 5 kg, 3 kg and 2 kg connected by a string shown in figure. Find first bit. Acceleration of the system. Second bit. Tension T1. Third bit. Tension T2. So your diagram is given. Like this is horizontal. A plane. The plane makes an angle theta. Theta is equal to 30 degrees. Five kg block. 3 kg block. Like this is pulling. 2 kg. 2 kg. So here in between 5 kg and 3 kg, one string is there. Next to 3 kg to 2 kg, another string. So here on the inclined plane, two masses is there. The acceleration along the inclined plane downward direction. So here acceleration upward direction. So here tension away from, let me take tension T1 downward, distance let be T2. T2 upward. So same thing, we'll draw the free body diagrams. And BD for, so before that one, let M1 is equal to 5 kg, M2 is equal to 3 kg, M3 is equal to 2 kg. Let T1 be the tension between 5 kg and 3 kg. T2 be the tension between 3 kg and 2 kg. Okay, so that means here let be M1, M2 and M3 and M3. So easy simplification purpose. So M 5 kg taken as M1, 3 kg taken as M2. So 2 kg taken as M3. Now ABD for mass M1. So at the same time here G also given 10 meter per second square. G value 10 meter per second square. Now mass 1 separated from the system. Theta. So where what is the theta? Theta is equal to 30 degrees is given. Mass 1. Weight of the mass 1 acts always vertically downward direction. Normal force, let me first block purpose N1. Here weight of the body resolved into component M1G cos theta downward direction along the inclined plane. M1G sin theta. Tension developed. T1 tension. What is the direction of acceleration? Along the inclined plane downward direction. So that means here resultant force F4 is equal downward mean M1G sin theta minus tension T1. So here F4 we have to write M1A, M1G sin 30 degrees minus T1. So M1 is given M1 5, 5A. So here M1 5 into G value 10, 50, 50 sin 30 degrees, 1 by 2 minus T1. So here 5A is equal 25 minus T1, 20 minus 25 minus T1. That's the equation 1. So M1 isolated from the system and draw the diagram showing all forces and make the equation. So here N1 is equal to N2. N1 is equal to M1G cos theta. Along inclined plane, perpendicular to the inclined plane, there is no motion. So that means normal force balanced by this one. So next one, ABD for mass M2. Mass M2. Same thing, mass M2 isolated from the system. Weight M2G. Normal force will be N2 perpendicular to the inclined surface. So your weight can be resolved to component. M2G cos theta equal to normal. M2G sin theta. M2G sin theta. At the same time, so T1 with respect to 5 kg upward direction, T1 with respect to 3 kg downward direction. And that will be a tensional force also. T1. Next to T2, up to here, T2 only. Upward direction, the acceleration of the body downward along the inclined plane. So along the inclined plane, how many forces? M2G sin theta and tension T1. Upward T2. Net force downward direction. So that will be here F4 is equal M2G sin theta plus T1 minus T2. This is we have to write M1A M2G sin theta plus T1 minus T2. M1 3A. So like this is 3 G value 10, 30 sin 30 value. 30 times 130 degrees. Sin 30 value 1 by 2 plus T1 minus T2. So 3A is equal 30 by 2, 15 plus T1 minus T2. Right, we equation 2. So next remaining in this system, 2 kg mass remaining. Now we'll draw the free body diagram for FBD for mass M2. Mass M2. Same thing, mass M. So mass M2, sorry, M3. Mass M3. So mass M3 isolated from the system and draw the diagram showing all forces. Here M3 weight of the body acts in downward direction, that is M3G. So tension T2 of forward direction. The acceleration of the system upward. That means mass M3 moves upward direction. So now net force is equal or resultant force. Fr is equal T2 minus M3G. Fr M3A is equal to T2 minus M3G. So here M3 value how much is given? 2 kg. 2A is equal T2 minus 20. So this is the equation 3. So 3 blocks are separated from the system and to draw the required diagrams and make the equation, 3 equations. Now requirement first question. First question, A of the system. For acceleration, equation 1 plus equation 2 plus equation 3, adding on both sides. Equation 1 plus 2 plus 3, add on both sides. So equation 1, right side 5A, second equation 3A, third equation 2A. Next first equation, right side 25 minus T1. Second equation, right side 15 plus T1 minus T2. Next third equation T2 minus 20. T2 minus 20. So left side 5A, 3A, 8A, 2A. 10A. 10A is equal minus T1 plus T1 cancel, minus T2 plus T2 cancel. So 25 plus 15, 40 minus 20. 10A is equal 20. That means 0, 0 cancel. A is equal 2 meter per second square. 2 meter per second square. This is the acceleration. Acceleration of the system how much? 2 meter per second square. Next, second bit what is asking? Tension T1. Second bit. Tension T1. Tension T1. In first equation, T1 direct is there. From equation 1, from equation 1, 5A is equal 25 minus T1. So from our equation, A is equal to 2 meter per second, we are substituting. A is equal in this equation substituting. So that means here 5 into 2 is equal to 25 minus T1. So T1 transfer here. Here 25, 5 into 2, 10, transfer that side minus 10. T1 is equal to 15 Newton. T1 is equal to 15 Newton. T1 is equal to 15 Newton. So remaining what is tension? Tension T2 asking. So tension T2, third bit. Tension T2. So tension T2. So in third equation, T2 tension directly is there. So 2A is equal to T2 minus 20. From equation 3, 2A is equal to T2 minus 20. So that means 2 into A value 2, T2 minus 20. So T2 here only, 20 transfer here, 20 plus 2 into 2, 4. So T2 is equal to 24 Newton. T2 is equal to 24 Newton. Okay, this is. So finally, I should remember all values. All values first bit. A is equal to 2 meter per second. Second bit, tension T1 is equal to 15 Newton. Third bit, tension T3 is equal to 24 Newton. Okay, this is conceptually solving very easy. Okay, thank you for watching. Please like, share, subscribe and support to me. Thank you for watching.